All right. I don't get many of those emails. Usually when you get one, it kind of concerns you. I want to know about a student. And 64.3. I'm just going to do it by whole numbers because I don't need that big of a deal as far as drawing it. Let's see, that's 3, so that'd be around 65 and 68, and minus 3, the 61 and 59, 58. All right, that's close enough for drawing your points. One woman is randomly selected. Find the probability that is less than, which means left of 65. So angle 65 is right here. So you want this area right there. So take your handy dandy z-score is equal to 65 minus 64, whatever, 0.3 over 2.9. Somebody give me that number. 0.24. Just 24 is all you need. And then you go to your handy dandy calculator, because I don't have a table up here right now, so I'll just have to I'll just put it today. Okay, second function, bars, I know number 2, I get number 2 and number 1 mixed up, I think it's number 2. And from negative, pick any number you want, negative infinity, 10,000, 10 million, whatever you want to use, but, comma, what, 0.24? Close parentheses, and I get 0.5948. Is that what y'all got? 0.5948. A lot of people say, well, Hubert, how do I know what to use for infinity? Well, it doesn't matter, because after you get past 99, it doesn't matter what you use. I'll show you. Second function. Enter, and let's just say you're lazy, which none of y'all are, and let's just put 99 in there. I think it's 99. I think that's the 0.5948. See, you use 100. Second function, entry. Back and use negative 100. Oops, I must have typed something in there. I put negative. I guess the calculator done formed a new number. I didn't know there was a negative 100. This thing said there is, and this thing calculated it in. There we go. I wouldn't go less than 99 though, because I think I did it one time, and I think it started changing that number or the fifth number, and then if you change that number or the fifth number, it would change that number. So I'd say past 99 would be good. All right, second part of the question. Says if 48 women, 48 women, so we got to go to the z-score and change the z-score because 48 women changes the whole dynamic. It changes, this is one woman, this is 48. So you just got to change the z-score. So let's do it in blue. So the z of 48 is equal to 65 minus 64.3 over 2.9 divided by the square root of what? 48. Well, the square root of 48, you don't have to be a rocket scientist. Square root of 49 is what? Huh? So the square root of 48 would be 6.9. So z of 48 is equal to 65 minus 64.3 over 2.9 divided by, what did I say? 6.9? Now do that denominator first. And what do you come up with? 2.9 divided by 6.9. 6 minus 64.3 divided by what? 1420. Is that what everybody got for the denominator? Okay, now give me that number. I mean the z-score. What is the final z-score? It's 60, wait a minute, 65, sorry. It's going to be positive, so it's going to be on this side again. What does it come out to be? 1.67. There's 1, 1.5, 1.67. Now, why does that happen? I want somebody to tell me why the blue is greater. Common sense. Just tell me why the 48 is the area is bigger than the red. It's just a common sense answer. Well, no, that ain't the right answer, but that's good thinking. That's 48 is bigger, so the probability will be bigger. No, think of it in terms of probability. One woman is randomly selected, all right, and they want to know if she's less than 65 pounds. Okay. Well, first of all, 65 inches. I was fixing to say 65 pounds. That's kind of light. 65 inches. All right. So one woman being 65 inches, that'd be, not many women. Most women. I don't know what the average height is for women, but in here it's 64. But in real life, I don't think it's 64 inches. Because what is 60 inches? Is 5 feet. Yeah, 65, 5.5. Yeah, okay, that's right. About 65 inches is what I thought the average height. So it's saying 60. What is the less than 65 inches? So that would be, 50%. That'd be pretty good. But why did it jump so much to say 48? Well, the probability of 48 women being less than 5 inches, again, 48 is higher, but the probability goes higher because the 48 is higher. And the probability of that's higher. So it's easier to understand that with the elevator question. Remember we did the elevator question, and it was like how many dudes in the elevator are less, or what is the probability of one guy being less than 156 pounds or more than 156 pounds? I can't remember what it was. And then it said, what is the chance that all of them? Well, the probability naturally goes up because it asks all of them. Just like this one. Is this one all of them too? I don't know. Okay, how many is in, okay, they don't say how many is in the group, do they? Okay, in 48, right here, if 48 are, if all of them, they all, find the probability that they have a, okay, well, they didn't say all, but the whole point is when you throw all in there, it kind of makes the probability get higher. So take the handy dandy calculator, and we go from -999 to 0.2. I can't find it. Where is it? I can't remember what y'all told me it was. What was it? What's the z-score? 1.67. The second function bars, or second function entry, -100 to 1.67. Close parentheses. Let's put something on. I'll put a point in front of it. I don't think we just want to do it. Bush's fault. 0.9525. Is that what y'all got? Mr. Vaughn, is that what you got? Thank you. I appreciate the interaction, Mr. Vaughn. Can't interact with nobody. But it's Monday, right? So y'all can act like that when you go to work. Y'all gonna act like that to your boss when he asks you for something on Monday morning? Huh? No, he's paying us. Oh, okay. That's right, all y'all gonna get F. Alright, what did we get for the first one? 0.59 what? Thank you, ma'am. And the second one? And next question. Alright. A statistics professor plans classes so carefully that the length of his class, her classes, notice it's not a he. Whenever he plans carefully, whenever the teacher plans carefully, it's always a what? A woman. Always. I've noticed that with these questions. Are uniformly distributed between, uniformly, highlight that. We went over two of them. They're in your notes. It's the rectangle. And I said there would be two questions on the test probably. Uniformly distributed between 45 and 55 minutes. Find the probability that the class period runs between 50 and a quarter minutes and 51 and a half minutes. Okay, these people have no life. Who cares? Right? One right out of 20. Thank you. How y'all like my redneck jar? That's really bourbon in there. Give somebody something to complain about. Huh? No, gin's clear. Probably because it was bad. No, I'm just kidding. Homemade. things here today. So next Monday is it, isn't it? I don't think it's ever going to get here. Alright, Bailey,
Good.
Bolt,
Good.
Clayton, Cowart, Dutchke's here, Escobar, Barr, Freeman, Hammett, Harris, Harvey, Hayes, Johnson, Mullins. Murray is not here. He's sick. Newton, Hoare, Perdesi. All my Robinsons are here today, I believe. Yep. Miss Scarborough's not here. Schuler, Simpkins. He might come late. I'm going to keep him a yes. Dennis is here. Smallwood. Both my Bones are here. Williams and Wood. I better leave that up there. Oh, Mr. Simpkins may not come in. I don't know. Alright, so uniform distribution. This one's not that hard if you follow the directions I gave you. So instead of curve, uniform distribution is that, and notice that what are we talking about? Pretty much the only thing that's uniformly distributed. Alright? The only thing that you cannot what? Change. The only thing you can't speed up or slow down. Although it does speed up after you get about 45, 30, it starts speeding up. Alright? So, they go 45 and 55 minutes. So 45 is here and 55 is here. So therefore, X is what? Your base is 10. So change that to X, change that to base. We all know that the area under the curve or the box is what? 1. So the area is equal to base times what? Height. So the height of our box is equal to 1 divided by 1 divided by 10 is what? 0.1. Please don't put that in the calculator. So the height of our rectangle is 10% or 0.1. Everybody with me? Now, let's take our handy dandy eraser And take out our 1 because that whole area here and here is 1. So we figured out the height and the width. The width is 10. We hold it over there. We can take our eraser and take these out and put 10 on the bottom, but we don't have to. But I'm going to take my blue marker, and it says, find the probability of selecting a class that runs between 50.25, let's see, 50 would be right here, so 50.25, and then put it right there. And 51.5. So 51.5. And then you want that area right there. So what's our base? No, not the blue. Blue is what? What's our base? Right here, people. What's that base? What's $51.50 minus $50.25? You have your money, and I'll take charge of your money if you want to add like that. 51.5, let's forget that. $1.50 minus 25 cents. What's $1.50 minus 25 cents? $1.25. All right. I asked it a while ago, and y'all like, oh, Patrick Scorpion. Oh. So base is 1.25. So 1.25. Now this is really hard work, people. All right, you might want to get your calculators out. 1.25 times 10% is 0.125. So that area is 0.1250. The only reason I add that 0 is that way it'll have 4 what? And that means it's what? An area probability or percentage. So your answer is 0.125. Now y'all should not get that one wrong. So you should have, let's see, there's 10 questions at 4 plus 40. So everybody should make a what on this test? A 50. Because there's 10 gimme questions and then there's 2 of these, I think. So that's at least a 50. Will everybody make above a 50? Nope. And it's all my fault. Right? When is the last day of this semester? Let's say September 11th. Wrong year. Alright, try this one. This one says, here you go. Assume that the readings on the thermometer are normally distributed, blah, 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 blah. Assume 2.1%, there's your area, are rejected because the readings are too high, and 2.1% are rejected because they're too low. Draw a sketch and find the cutoff values. So which picture is it? See? Yep. Negative 2.1 down here and 2.1 right here. Greater than 2.1, less than negative 2.1. So all you have to find is the negative 2.1 and the right hand side, which would be 2.1, the complement of 2.1, because you've got to find the right hand side. Look at it again. This is the right hand side, so that would be the complement of 2.1, positive 2.1, because positive 2.1 gives you this whole area right here. So look up your handy dandy table. Negative 2.1, negative 2.10 is 0.0179. 0.0179. Oh, we've got to give scores. Yeah, okay, it's okay. 0 and 1, it's okay. 0.0179, or did I look up the wrong one? Oh, we got to do the area. We got to do the area. We got to get the z-score. Sorry. 0.0210. Let's see, move 1 to 0.0210. So let's look for 0.0210. So 0.0210, that's $2.10. What's closer, $2.07 or $2.12? Huh? 12 cents. So that's negative 2.03, right? Negative 2.03 is what I got. So negative 2.03, comma, and the other one's going to be 2.03 on the positive side, I think. Should be the same. Those are both equal. But we'll look. And that's going to be, somebody take 100 minus, or 1 minus 0.021. What do you get? Y'all all don't speak at one time. 100 minus 0.021. What do you get? Alright, we got to find 0.979. 0.979. That's 0.979 is $9.79. What's closer? Let's see, there's 979. 979.3 or 978.8? Which one's closer? 9788, Hubert. That's right, class. So 2.03, so it's the same. And next question. Now you could also do that on the calculator, right? What do you do? Second bar's norm, Hubert. That's right, class. Inverse norm of .0210, close parentheses, and inverse norm, or second inverse, or second entry, and put, what was the other one? 0.97 what? 0.979. My stomach hadn't bothered me for a while, and it's bothering me today. 2.3. So you can do inverse norm and put the area in. The only reason I add the 0 is for consistency. When I teach y'all this section, whenever you see 4 digits, that means you're dealing with an area. That's why I do that. Okay, let's put two questions right together. It's not supposed to do that. Assume that the readings of the thermometers, this is the same question. Oh well, no it's not. It's not exactly the same. Assume the readings on the thermometer 0 and 1. The thermometer is randomly selected. Draw a sketch and find that the temperature reading corresponding to the 86th percentile. That means separating the bottom 86%, less than 86%, and greater than 86%, or the top 14. So they want that number at 86%. So that's 0.8600. So, that would be which one? Which one is around 86%? Well, it's not A or C, is it? Because that's what? That's not leaving 50%, is it? And this mark right here ain't even at 50%. So A and C is not it. B is in Bravo. Yep. That's it. No more sneezing, class. Gosh. Let's see. So 0.86%. So that's $8.60. Right? So let's go to $8.60. Look on our handy dandy right table. $8.60. Okay, here's 86.65. Let's see, $8.60. Okay, what's closer? $8.62 or $85 or $8.59? Which one's closer? This one. So 1.0 what? 8. Dang old. 1.08 degrees. Alright, try that one. Assume that a woman's heights are normally distributed, blah, 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 blah. Complete parts A and B. This is 6.5. So 63 is in the middle, and 63 plus 2 would be 65, And 65 plus 2 is 67. I'm doing whole numbers. You need to do the decimals. 63 minus 2 is 61. And 61 minus 2 is 59. And you don't necessarily have to do the decimals if you don't want to. It's not like you got to do that to pass the test. You just draw the picture. You can just use whole numbers. And then we'll take the red marker and mark our spot at what? If one woman is randomly selected between 62.9, 62.9 is right below 63, and 63.9, which is right at what? 64. So even with the calculator, you still need to have a z-score here and a z-score here. And whether you use the table or the calculator depends on you. Can you please drink some orange juice or something? Dang old vitamin C. Alright. So, dang old 62.9 minus 63.1 divided by 1.6. What do you get? It's going to be negative. What is it? Okay, it wasn't that complicated. 62.9 minus 63.1 divided by 1.6. Huh? Does nobody have a calculator? Or 0.12? 0.125, that'd be 0.13, wouldn't it? 0.13, and what's the positive? What's 63.9 minus 63.1 divided by 1.6? 0.8 even. And there's your two z-scores. So you take your handy dandy calculator and type in second bars, or you can type in second entry, or second enter, second enter, second enter, and you're back to normal CDF. And we're going to type in negative 0.130. I'm just putting that 0 so I can, well, don't have to, 13, and then comma 0.80, just to keep my decimal places in the calculator. I get 51.5758, 51.58, 0.5158. Huh? I did? Well, horse cookie. It's a conspiracy. Thank you. 0. .3397. 0.3397. All right, now do the next part. It says, if 5 women are randomly selected, see if their heights are going to be between, see what the probability of their heights would be. If 5 women are randomly selected, well, you got to have 2 more z-scores. So we're going to take our pink marker. No, that'll clash. Let's go with brown. And give me that z-score, which is going to be your regular 62.9 minus 63.1 divided by 1.6 divided by, what is the square root of 16? 4. So the square root of did I get that? I'm sorry. 5. I don't know where I got 6 from. Anyway, the square root of 5 is what? 2.14? Yes, Hubert. No, Hubert.
2.2.
Okay, 2.24. Alright, so plug that in there. And what is your new left-hand z-score? It's going to be bigger, it's going to be less than negative 0.13. What is it? Negative what? I thought it would be smaller, but it's bigger. 0.058 be 0.06. Alright, somebody give me the right hand side, which would be 63.9 divided by 63.1 divided by 1.6 divided by 2.24. What do you get? It's going to be positive.
0.22.
Okay, it narrowed it down. See, this one narrowed it down. So this one is like here, and negative 0.06 is even smaller. So this one made the area smaller between the two brown lines. And you take your handy dandy calculator, 0.06 to 0.22. Oh, that ain't doggone it. I think I just need to quit. Negative 0.06 to 0.22. And that area comes out to be 0.1110. Next question. That's pretty simple. Alright, try that one. Assume the readings on a thermometer are normally distributed with a mean of 0 and a standard deviation of 1. So that means this is 6.2, just like the other one was. Find the probability that randomly selected is greater than negative 1.54. Which one's showing greater than negative 1.54? A. So that means you got to find the complement. The right hand side is equal to 1 minus the left hand side. So, or if you have a calculator, you can just do the right hand side. But if you're using the table, you have to use the complement. So get to it. And Mr. Simpkins is here. And I'll wait on you, Mr. Simpkins. I just turned the roll in on attendance for the bureaucrats. So you take your handy dandy calculator and you can just, I'm going to do this one in the calculator, be negative 1.54 to what? Infinity, Hubert. That's right, class. Insert second function, delete, put 1 in there, point, 5, 4, to what? 9999. That's good, Hubert. Thank you, class. I get 0.9382. That should be what you get. 0.9382. Will Hubert's exam be online? Oh, sorry. Sorry. I have to go back to the roll. There we go. Assume that the readings on the thermometer is 0 and 1, so this is 6.2 again. Assume 2.3 too high and 2.3 are too low. So that means 0.023. So I'm going to do it in the calculator. And that'd be second function, bars, inverse norm. And we're going from, is it between? They're asking for between. Okay, outside. So that'd be, well, it'd be the same. Just one would be negative, one would be positive. So it'd be 0.023. So 0.0230 and enter. And that's going to be negative 1 point, or negative 2 and positive what? Positive 2. So A is your answer there. And negative 2, comma, positive 2. Inverse norm. And what are you going to type in for this one? I'm asking y'all, that's not rhetorical. What you gonna type in? .9700, Hubert. That's right, class. .88. Well, that's not what they're asking. What are they asking for? Huh? So they're looking for X, aren't they? X is equal to what? Oz plus mu. Thank you. So somebody take a calculator and multiply 15 by 1.88 and add it to 100. What do you get? I'll do it. Times 15 plus what? 100. So that'd be 128.2. When is the week of finals? Only possible answer. Alright, try that one. I'll blow it up for you. I don't know what's worse, a toothache, a stomach ache, or a headache. All three are very annoying. That's the best word to describe all three, annoying.
Okay. I think everybody just must have partied too hard this weekend. Is that what it was? I hope y'all ain't like this in all y'all's classes. It's a long day if it is. All right, negative infinity to 110. So put that in your calculator, and of course you're not going to get the right answer. We had to change 110 to dang old z-score. So 110 minus 100 is 10 over 15, which is what? 2/3, which is 0.67, right? Yes, Hubert. Thank you, class. Thank you. Y'all settle down. Negative 9999999, comma. I forgot what I said. 0.67. Close parentheses. I get 0.7486. .7486. Alright, assume the readings of the thermometer. This is out of 6.2, so this one's real easy. Greater than means what? Right hand side. So if you're using your calculator, you're going to go from what? What are you going to go from? Negative 2.3 to infinity, Hubert. That's right, class. Thank you, class. If you're using the table, you've got to use the complement. Yes. So negative 2.3 or negative 0.23 to infinity. Enter. 0.590 or 0.591. Because he hates me. Yep, that's it. Good gracious, y'all need some daggone vitamin C or something. Bunch of unhealthy people. 18. I have no idea. Midnight, even though I don't do it. Boy Scouts. I hit the button. Donald Duck. Alright. Lengths of pregnancy are normally distributed with a mean of 268 days and a standard deviation of 15 days. Find the probability that a pregnancy lasting 309 days or longer. That's A. B. If the length of the pregnancy is the lowest 4%, then the baby is premature. Find the length that designates a baby as premature or not premature, which is a complement. Draw a picture. class over? I'm sorry. I didn't know what time it was over. What time's class over? What? Okay. Well, let's see how many we got right. We got 20 done, right? Well, there's a couple we got wrong. What's wrong with that one? Oh, I picked the wrong. Okay, I picked the wrong picture. Well, I'm sorry, I picked the wrong picture. Why did I get 6 wrong? Oh my gosh, we did one wrong. Oh well. One woman between. How did we do that one wrong? We must have calculated the wrong Z-score. Vanna, what did we do wrong? Y'all suck. Alright, we got one wrong out of 20, so I made a 95. Y'all have a good day.
You too. It's not bad to see. It's Alex.